Asma has 24 blue roses and 15 red roses. She wants to make the largest number of bouquets contain the same number of roses of each color. Write the numerical expression shows the total number of roses. So the words largest number of bouquets is a keyword to get the GCF between these two numbers, 24 and 15. The greatest number of, the largest number of, the biggest number of, all of them mean to get the GCF. The GCF will tell me the largest number of groups. I can divide the two numbers equally inside them without any leftover. So the first thing is to get the GCF, then using the GCF and the distributive property to write numerical expression. So let's get the GCF first between what? The two numbers 24 and 15. To get the GCF, I have to factorize 24 and factorize 15. So to factorize and get the prime factors of 24 and 15, I write any factor pairs instead of one by the same number. So I write any factor by any factor to get me 24 and 15 as well. I can write 2 by 12 or 3 by 8, 4 by 6, so I can factorize it as 4 by 6. 4 is a prime number? No. So factorize again. It's gonna be 2 by 2. 2 is prime, make a circle and stop. 2 is prime, make a circle and stop. And these 6 will be factorized to be 2 by 3. 2 is a prime number and 3 is a prime number also. What about 15? 15 is 3 by 5. 3 is a prime number. 5 is a prime number. Then make the Venn diagram to get the GCF. So I'm gonna make a circle to put the factors of 24 and another circle to represent the factors of 15. And I'm gonna write all the factors inside this Venn diagram. So first 2, does it have a common factor here? No, so gonna be outside. 2, is there any common factor or any other 2 also? No, so gonna be outside. This 2 has a common factor? No, so gonna be cancelled and write it here in the outside circle. 3 has a common factor there, so cancel, write it once. I write it once in the shared area. The common factors between the two numbers will be written here inside the shared area. What about 5? No common factor with 5, so gonna be outside in the circle of 15. Now to get the GCF, I will look at the middle in the shared area or the intersection area, who's inside 3. So the GCF here gonna be 3. Now I will use the GCF to write the numerical expression as I said. So numerical expression means you will use the GCF you got and the distributive property to get the numerical expression. So first, the total number of the roses is 24 plus 15. I have here 24 blue roses and 15 red roses. So I'm gonna use this GCF, which is 3, and open a parentheses. Inside these parentheses, I write the other factors outside in each circle of each number. So 3 by how many blue roses? 2 by 2 by 2. 2 by 2 equal 4. 4 by 2 equal 8. Plus how many red roses? The outside factor here is 5, so gonna be 5. So it will be 3 by 8 plus 5. This 3 is the number of groups of the number of bouquets I can make. This is the largest number of bouquets, and this 8 shows the number of blue roses in each bouquet, and 5 is the number of red roses in each bouquet. So the largest number is 3 bouquets. In each bouquet I have 8 blue roses and 5 red roses, and the last expression I'm gonna write 3 by 8. I will distribute 3 by 8 plus 3 by 5. So the 3 sentences are the same. This is the total, and here I used the GCF and the distributive property. Then I distributed the GCF over the 2 factors inside the parentheses.